So, hello dear student. In this class, we are going to see the solution of AIT 3 chemistry NEET paper, right? So, this is going to be a very important session for all of you. जिस बच्चों को भी जहां जहां भी डाउट था जहां जहां भी प्रॉब्लम था तो वी आर गोइंग टू सी ऑल द कंप्लीट सॉल्यूशन इन दिस वीडियो ठीक है तो चलो लेट्स स्टार्ट विद द टुडे क्लास. Right. So the first question is that is the number of BOB bond present in the borax, right? That is Ne2B4O7. So this question is very important. Sometimes they are asking number of BOB bond. Sometimes they also asking the number of BOH bond is also right. So these type of questions were coming in a previous NEET or we say JEE main paper. So this is very important question to all of you. I hope सबने सही किया होगा. Many of you did this question very correctly. तो फटाफट देखते हैं व्हाट आर द सॉल्यूशन फॉर दिस क्वेश्चन राइट. So let me first draw the structure of the this Ne2B4O7, right? Because this is very important. So if I'm talking about this, so this having, right? So this having, let me draw the structure first, right? So they having the structure like HO, that is having OH bond, that is B, right? O, again they have O, B negative, OH, O, again they are having B, and this is again OH, right? Similar on this bottom side, we have B negative, that is OH we have, and we have O, and one O between this, right? Between these two B, that is boron and boron. So we have to calculate the number of BOB bond present. So how many BOB bond present, beta? BOB. So we have a one BOB bond here, two BOB bond, three BOB bond, and this is four BOB bond, and total we have a five BOB bond, one between in the center as well. So total number of BOB bond present in this is five. So this is what they are asked in the previous question, that number of BOB bond you have to find. Suppose if they are asking number of BOH bond, right? Then what is your answer if they are asking number of BOH bond? So we have a BOH bond like one BOH bond here, one BOH bond here, two, one BOH bond here, three, and one BOH four. That is four. So BOH bond is equal to four, and here BOB bond, right, is equal to five. So in this question they're asking only number of BOB bond. So that's why the correct answer is D, right? So this is the correct one. I hope this is clear to everyone. Chalo, move to the next question. That is choose the incorrect reaction, right? You have to choose the incorrect reaction. So we have a SO3 in presence of D2, or they will give D2SO4. Or we have a Zn plus concentrated H2SO4. This will give ZnSO4 plus H2. We have MnO4 negative plus H2O2. In case of peroxide, they oxidize them into Mn plus 2 and NaH, right? So they will form NaOH plus H2. So you have to select the incorrect option. So beta, always remember this point. This is very basic and very fundamental thing. Zinc doesn't form ZnSO4 when they react with the concentrated H2SO4. Always remember beta, right? Because whenever the zinc react with the concentrated sulfuric acid to form zinc sulfide, and hydrogen gas will be evolved, right? So always zinc sulfide will be formed whenever they react with the H2SO4. Zinc sulfide will be formed and hydrogen gas is evolved. So this is absolutely incorrect statement for this, right? So this is also a very memory based, or we say concept based question. Now move to the question number 53. That is, in an atom, which subcell is filled by electron after the 4p? So this is according to the above principle. We all know that the filling of electron like 1s, 2s, 3s, 4s, 5s, and 6s. Similarly, we have a 2p, then 3p, then 4p, then 5p. Again, we have like 3d and 4d and 5d, right? We fill the electrons according to this order, right? According to this arrow. Now tell me, after, in this question they're asking, in an atom which subcell is filled by electron after 4p. So after 4p, which will form beta, that is 5s, right? So which electron will fill after 4p? That is 5s. So I hope this is very simple question and everyone did this question, did the solution for this question very easily, right? So I hope everyone got it. Now move to the next question, right? So in this question, they're asking the radius of an atom of an element is 75 picometers. So the radius of an element is already given, and the lattice is body center cubic. So you have to calculate the age length of the unit cell. So this question is from the solid state chapter, right? Where the radius of an atom of an element is already given, that is 75 picometer, and the BCC, the crystal is type of BCC cubic. So you have to calculate the age length for this, right? So we know a very basic formula for the BCC. What we know, beta? That for BCC, because we know that for the BCC, that is R comes out to be under root 3 by 4, under root 3 by 4 A, right? And this A you need to calculate. So what is the value of A? A value comes out to be 4R divided by under root 3. So just put the value. We have 4 and the value of R is 75 picometer, and root 3 we all know that is 1.73. So on calculating, value comes out to be around 173.2 picometer. So out of this, option B is absolutely correct. So this is very simple question from the solid state. Okay? Chalo. Move to the next question, beta. That is, considering the entropy as a thermodynamic parameter, the criteria for the any reaction to be spontaneous. So this question is from the thermodynamic second law, and they are asking about the criteria. What criteria generally defined for the process to be spontaneous, right? A reaction to be spontaneous. So in this question, the first option is that is the energy, the entropy difference, that is entropy of system minus entropy of surrounding must be greater than 0. Entropy of the system is greater than 0. Entropy of the surrounding is greater than 0. Or the sum of the entropy of system plus entropy of surrounding is greater than 0. So they are asking in this question. So we all know that for the spontaneous reaction, the sum of the entropy, that is the total entropy, right? That is the total entropy. S total must be greater than 0, then only the process is said to be a spontaneous in nature, right? So for the spontaneous reaction, the total change in entropy must be positive. So we can say that option D is absolutely correct for this, right? So clear as sabko, I hope. Chalo. Now, the next question is when the 3-phenyl propane on reaction with HBr give major product. So this question is from the Marconi's rule, right? This is question from the Marconi's rule, that is 3-phenyl propane on reaction with HBr. What will they give, right? So whenever the 3-phenyl propane react with HBr, right, according to the Marconi's rule. So first of all, this is 3-phenyl propene, not propane. This is propene, right? So when the 3-phenyl propene react with HBr, what they will give as a major product. So let us discuss the reaction for this. So we all know the structure of that is C6. This is H5, and we have a propene, right? So propene means we have a CH2, we have a CH double bond CH2. So this is we have a propene, that is a phenyl propene, right? Or we can say that this is a 3-phenyl propene, 3-phenyl propene, and this will react with HBr. So according to the Marconi's rule, this negative part goes to those carbon atoms which contain the lesser number of hydrogen on the double bond. So we can say that this will go to this, right? This will go to this HCH plus, right? So whenever this will takes plus, the formation is like we have this carbocation. So we can say that the formation is like this will be C6H5, C6H5, and this is CH2 we have, and this is CH, and here we have Br, and here we have CH3, right? This case is also possible, but here due to hydride shift, right? Due to hydride shifting takes place, right? Okay, hydride shifting, the product is become C6H5, and the most stable carbocation is this, right? More stable carbocation is this. So Br will go to this Br, and then CH2, and this they will become CH3. So the correct product is C. So the correct product is C for this question, right? So C is the correct answer. Whenever the 3-phenyl propene react with HBr, it will give major product as this, right? Due to hydride shift, we get this product. Otherwise, we'll get this product. Chalo. So move to the next question, beta. That is question number 58, right? So in this question, they are asking at 500 Kelvin, the half-life period of the gaseous reaction at an initial pressure, right? At an initial pressure, okay? At an initial pressure of 80 kilopascal is 350 seconds. When the pressure is 40 kilopascal, the half-life period is 175 seconds. What is the order of the reaction? So you have to calculate the order of the reaction for this. So it's a very simple formula. We know all how will you relate the pressure and the half-life time, right? For calculating the order of the reaction. Okay. So the pressure is given. All values are already given. Like we have a P1. So P1 is given like 80 kilopascal. So P1 is 80 kilopascal. Similarly, we have a P2 which is equal to 40 kilopascal. We also have a T half one, है ना? T half given है for the first condition when the pressure is 80 kilopascal. So T half is 350 second, right? Similarly, we have a T half for the second case when the pressure becomes 40 kilopascal. So T half is equal to 175 second. Right, 350 second and 175 second. So now what to do? Just use the formula like P1 is divided by P2. The ratio of the pressure is equal to ratio of the half time, that is T1 by T2, right? And this is for the condition 1 and this is for the condition 2. So this is the standard formula. We all know this thing, right? So how will calculate by using the value? So we came to know that is the ratio of the concentration of the reactant will be proportional to the pressure. The ratio of the concentration of the reactant will be proportional to the pressure as we have been given initial pressure, right? As we were given initial pressure. And since the half-life of the reaction is directly proportional to the reactant concentration, we can say that this is a zero order reaction, right? Because in the zero order reaction only we came to know that is T half is equal to R naught upon 2K, right? That is T half is directly proportional to the initial concentration, right? So from this we can get to know that this is in a zero order reaction because here we can came to know that P1 by P2, that is the concentration of the reactant, is directly proportional to the half lifetime. So if the concentration, because here we can say now that is a T half is a 80 kilopascal. When the pressure is 80 kilopascal, T half is 350 second. When the this becomes 40, then T half also reduce to 175, right? So we can say that this concentration of the reactant is directly proportional to the half lifetime, and whenever half lifetime is proportional to the concentration of the reactant, we can say that this is a zero order reaction. So the correct option is A for this, right? So this is the correct option. Now move to the next question. So this question is from the Nernst equation, that is consider the cell at the 25 degrees Celsius. We have a titanium to titanium plus and that concentration is already given, and copper to concentration is also given, for which EMF is 0.84. So already EMF is given. The EMF of the cell could be increased by. So you have to, in this question, they're asking, how will you increase the EMF of the cell? So we all know that beta, how to calculate the EMF of the cell. So EMF of the cell is nothing but standard EMF of the cell minus 0.0529 divided by n, and that is the concentration, that is a we can say that log concentration of the product, right? Here we have a titanium plus as a product divided by concentration of the reactant, that is copper plus 2, copper plus 2. So we can say that how will you increase the EMF of the cell? Okay, so the cell equation can be represented as we know. Now, the increasing the concentration of the copper 2 plus, if you increase this concentration, this value become lesser. The log titanium, the ratio of the titanium plus to copper plus 2 become lesser if you increase the value of copper 2 plus. So we can say that this negative quantity, whole negative quantity, right? This whole negative quantity reduces, And when this reduces, definitely E cell will be increased, right? So we can say that by increasing the concentration of copper 2 plus would increase the EMF of the cell, right? Because what happen if you increase the concentration of copper 2 plus? When you increase the concentration of copper 2 plus, ऑटोमेटिकली क्या हो रहा है, द रेशियो है ना ये कॉपर 2 प्लस, इन दोनों की वैल्यू तो डिक्रीज होगी। और कब, क्योंकि जब भी नीचे बड़ा डिजिट होता है उसको डिवाइड करते हैं वैल्यू छोटी हो जाती है। एंड व्हेन यू डिक्रीज अ स्मॉलर क्वांटिटी फ्रॉम दिस, देन बिकॉज दिस इज अ होल अ नेगेटिव क्वांटिटी, so whenever this negative quantity is very small, always we get the good amount of EMF, right? So by increasing the concentration of copper plus, we can actually increase the EMF of the cell. So this is also a very, very interesting question. Now, move to the next question. That is the volume of the fixed masses of gas as 27 degrees Celsius and constant volume is V centimeter cube. Its volume at 227 degrees Celsius is. So in this question, the pressure is constant, we have to calculate the volume, and two temperatures are also given. So this question is very simple, and this is from the states of matter gaseous law, right? That is T, P, and V. P, that is a Boyle's law, and this is a Charles law, Gay-Lussac law. So this question is from the Charles law, right? So this question is from the Charles law, which states that beta, that is V1 upon T1 is equal to V2 upon T2, right? And you just need to calculate the V2. So V2 comes out to be V1 into T2 divided by T1. So what is V1 in this question, beta? So V1 is already given, that is the volume for the fixed mass of gas at 27 is constant pressure is V centimeter. Its volume at this, right? So V1 is already given V, and we have a T2. So T2 we have a 227 divided by 27. Right. So when you solve this, you'll get the value like 5V by 3. So 5V by 3. Yeah, that is option D. So option D is absolutely correct. Right. So option D बिल्कुल correct है, बहुत simple question था ये। चलो, move to the question number 61. Right, move to the question number 61. So the following data were obtained during the first order decomposition of 2A plus BC at a constant volume at a particular temperature. So we have a two serial number 1, 2, and the time is given, total pressure is given. You have to calculate the rate constant for this, right? You have to calculate the rate constant. So this is also a formula based question. We know the how to calculate the rate constant, that is K is equal to 2.303 divided by T, and this is log, right? This is log, and this is pi upon 2 pi minus pt, right? This formula you need to remember. So let us calculate the rate constant at t is equal to 10 minutes, right? After the rate constant in minute you need to calculate, right? So rate constant, that is 2.303 and divided by t, that is a 200 when the time is become after the completion and at the end of 10 minutes, right? So at the end of the 10 minute, total pressure is 300, and after completion the pressure is become 200, right? So you need to calculate this. So this time become 10 minutes. So this is 10. Initial pressure is what, beta? Initial pressure is that is 300. So this is the initial pressure. We have 300, and this is 2 into 300 minus 200. So just you need to solve this. When you solve this value, you'll get the value, right? That is 2.303 upon 10 into 300 divided by 2 into 300 minus pt minus, this one is 2 pi minus pt. So you get the value like 0.0693, right? So the correct option is A, right? So the correct option is A, that is 0.0693. Right? So this question is from the chemical kinetic part. Chalo. Move to the next question, beta. That is question number 62. That is a pure ethylene gas CH2 double one CH2 occupy a volume of 8.21 liter at 27 degrees Celsius and 2 atmosphere pressure. The mass of the gas in gram is. So you have to calculate the mass of the gas in gram. So this question is also from the states of matter, and it's a very simple question from the ideal gas equation, that is PV is equal to nRT, right? PV is equal to nRT, and we know that PV and N is nothing but mass divided by molar mass into R into T, right? So you have to calculate this small m. So this small m is like, that is PV divided by RT into M. So just put the value, all value you know, M is equal to, we know the value of P, we know the value of this. So on putting the value, uh, add to atmospheric, so pressure is 2, volume is 8.21 liter, and molecular mass of ethyl, right? So molecular mass of ethyl we can calculate, it comes out to be 28. It's very simple. That is CH2 double bond CH2 ethane. And R we have, R is also given, right? Or we remember the value of R, that is 0.0821, and the temperature is 27, that is 300 Kelvin. So on putting the value, you'll get the mass. So mass comes out to be 18.67 gram. So which option is correct, beta? That is B. So option B is absolutely correct. Now, move to the next question, that is question number 63. That is alkali metal from hydrated compound. The tendency of an alkali metal to get hydrated is in the sequence. So you have to arrange them into sequence. So you already know this thing better. This is a very straightforward question. That is smaller the size of the smaller the size of the cation, because as we move down the group, hydrated tendency reduces. So we can say that smaller the cation, greater is the degree of hydration. So the degree of hydration decreases from lithium to cesium plus, right? Always remember, smaller the cation, greater is the degree of hydration. So we can say that lithium, then comes sodium, potassium, rubidium, and cesium. So this is a very simple question. Chalo. Move to the next question, that is question number 64. So in this question, they are asking which of the following solution which have the lowest freezing point. So which of the following has the lowest freezing point solution beta, ठीक है? तो चलो फटाफट देख लेते हैं which of the following having the lowest freezing point solution. So we can say that in case of Li2SO4, what is the Vento factor beta? We have a 2 mole of Li plus 1 mole of SO4. So we can say that here the value of I comes out to be 3. Now, in the second case, the value of I is like CaCl2. So here also we have a 2 mole of Cl plus 1 mole of calcium. So here also the value of I comes out to be 3. Now in this case, the value of I in KCl, the value of I comes out to be 2. Or in case of CH3, CH2, the value of I comes out to be 1. So in the, because this is a covalent compound now. So in the fourth case, the value of I comes out to be 1. So in this, we have a maximum value of 5. Now let's see their concentration of each of having. So they're having the concentration of 0.015. They're having 0.01. So obviously they having the more concentration. So we can say that this will having the lowest freezing point depression, right? This having the lowest freezing point depression, because when you multiply 3 into 0.015, you will get a 0.045 mole, right? 0.045 mole. And when you multiply this 3 with the 0.0100 m, then you'll get only 0.03 mole. So obviously number of mole in this case is much more. That's why they're having the lowest freezing point. Okay? So this question is from the Vento factor and solution chapter. Chalo bhai, move to the next question. That is, when the oxalic acid is heated, it will give A plus B plus C. A burn with the blue flame and it's oxidized to gas B. B turns lime water milky. So you have to identify this A, B, C, D, and E. So this is very interesting question from the organic chemistry. So whenever the oxalic acid is heated, you will get ABC. So let me write the reaction first. So we have an oxalic acid. The formula of oxalic acid is like this. That is COH. When they are heated, जब भी heat करेंगे, you'll get CO plus CO2 and plus H2O. So three things will get CO plus CO2 and plus H2O. Now this CO, A burn with the blue flame and oxidize to gas B. So it oxidized to gas B, right? So it oxide. This is A and this is B, right? So it is very understood that is A is CO and B is must be CO2, bit oxidized to gas B. B turns lime water milky. Yani it means when the CO2 is treated with the CaOH2, that is calcium hydroxide, it convert this into CaCO3 plus H2, that is CaCO3 plus H2, right? Now, when the A react with the Cl2, that is when the CO react with the Cl2, they will form basically COCl2, which on further reaction with NH3. NH3, they will form NH2 CONH2, right? That is urea, right? So here we get to know what is A, what is B, what is C, and what is D. So A क्या है भाई? A फटाफट बताओ. A is CO, right? So which option is correct? First of all, the C option. That is A is CO, B is CO2, and A, B, and C. And C is H2. So this is C. Now, again, D is NH2CO, NH2, that is urea. So option C is absolutely correct. This is very, very interesting question, right? Chalo. Move to the next question, beta. That is Al2O3 is reduced by electrolysis at low potential and a high current. If 4 into 10 raised to the power 4 ampere of current is passed through molten Al2O3 for the 6 hour, what mass of aluminium is produced? Assume 100% current efficiency and atomic mass of aluminium is assumed to be 27 gram per mole. So it's a very simple thing that whenever Al plus 3 reduces, it means when they accept this 3 electron to become Al, right? So here we can get to know the number of electron. So the number of electron is 3f, right? Now quantity of electricity passed Q is equal to I into T. So we have a I is equal to 4 ampere and T is also given I having 4 into 10 raised to the power 4 ampere and time is also given that is for 6 hours यानी इसको कर लो seconds में. So 6 hour को second में किया 6 into 3600. ठीक है. So it comes out to be on solving 4 6 the 24 and this. So this comes out to be 8.64 into 10 raised to the power 8 coulomb. ठीक है. Now this much this much of the quantity of electricity passed. Now it's a very simple thing from this equation, that is 3f. So 3f electricity deposit, molecular mass of this is 27 gram of aluminum. So 3f quantity deposited 27 gram. So this much 1 gram is 1f deposited 27, right? 27 divided by 3. 1f. So how many quantity of charge we have? That is 8.64 into 10 ki power 8 coulomb. So this will deposited, that is 27 divided by 3, and 1f value we all know that is it is equal to 96,500, right? And multiply by 8.64 10 raised to the power 8. So the value comes out to be on solving 8.06 into 10 raised to the power 4 gram. Right. So which option is correct, beta? Definitely option A. So option A is absolutely correct. ठीक है? Let me explain this question once again. In this question, they are basically asking, that is, what mass of aluminum is produced. So we know this in this, that is 3F, right? So 3F, that is equal to their molecular mass. 1F, we also 96,500 coulomb. In 1F, we have a 96,500 coulomb. So we can write here better as 96,500 coulomb will produce 27. So 1 coulomb will be produced how much? Right? Because we have a 3F now. So this is 3 and 96,000 coulomb will produce 27 upon 3 gram. So this much of coulomb will produce this much. ठीक है. तो इस तरीके से हम लोगों ने इसको फाइंड आउट किया है. चलो, move to the next question, beta. That is question number 17. So we have a phenyl CH3, OH, CH3, and they react with H plus to form this. Now the correct statement for the above reaction. Reaction proceed via carbocation mechanism. Yes, it's absolutely true. This reaction proceed via carbocation. Now migrating order of aryl group is more than the alkyl group. This is also very much true, beta. Migrating order of aryl group is much more than alkyl group. This reaction is called pinacol rearrangement. Absolutely correct, Peter, because we have a two alcohol group here, right? And we have a ketone group here. So this reaction is called pinacol rearrangement. So we can say that all of this correct, all of the above statement is true for this reaction. Okay. So the correct answer is D. Now, move to the next question. That is question number 72. So, the ionic hydrides are formed by all the S block element except. So, this is very, very simple question. Better we all know this. Magnesium and beryllium, they are only the covalent, make a covalent compound due to the smaller size, right? The rest, all the element will form the ionic compound. So, except magnesium and beryllium because they are very small, rest all elements form ionic hydrides. Magnesium beryllium do not form ionic hydride. ठीक है. चलो. The next question is 2-hexene gives trans 2-hexane on treatment with. So we have a 2-hexene, right? So we have a 2-hexene, that is hexine, and this will treatment give trans 2-hexane on treatment with which of the following. So let me tell you one very important concept here. Whenever they are treated with NaNH3, they will produce trans 2-hexene, right? Whenever they will treated with the PDBSO4, PDBASO4, they will produce cis 2-hexene. Huh? And whenever they are treated with the PT, that is platinum NH2, they will produce N-hexane. They will produce N-hexane. And when they are treated with the LiLH4, no reaction will take place. So this is very important to learn beta whenever they having same, right? So whenever the 2-hexene is treated with the sodium in presence of ammonia, we get the trans 2-hexene. This is the part of our question. So the correct one is sodium in liquid ammonia. But the additionally, what you will get the information here, whenever they will treated with the PDBSO4, you will get cis 2-hexene. Whenever they are treated with the PTH2, you will get N-hexane. And with the LILH4, they do not give any reach. Okay, so this is very, very important question to learn many things from this question. Chalo. Next question is 74. So a solution of the two liquid boil at the temperature more than the boiling point of either of them, hence. So the binary solution so a by solution of the two liquid boils at the temperature more than the boiling point of either of them. Hence the binary solution will follow. So in this they are asking. So basically, they will show the negative deviation from the Raoult's law because they're having the more boiling point, right? So in mixture with the negative deviation from the Raoult's law, the vapor pressure is lower than would be expected from the Raoult's law, right? Which produce the boiling point higher than the expected. So we can say that this will show negative deviation from the Raoult's. Move to the next question, beta. That is question number 77. So what the 77 question asks basically. So the three sets of elements are given below. We have a boron, aluminum, gallium, and beryllium. So let me arrange this all. So this is boron, neum, gallium. Hmm? And we have a beryllium, right? Beryllium also. So this is from group 2, this is from group 13. Now what they are asking, which of the following sets contain an element which does not belong to the group 13 and yet its properties are quite similar to one of the group 13 element. So beryllium shows similarities with aluminum beta. So obviously that is a what they are asking, the three sets of element are given below, one, two, three, four. Three. Which of the following sets contain an element which does not belong to group 13? So we have boron, aluminum, gallium, and indium. Right. So right? They are boron, aluminum, thallium, rubidium. So basically, third one and the first one, right? First and third. So the first and third, or we can say that boron having in group 13, aluminum, thallium, bangan, alu, gajar in thala, right? This is a group 13. We have indium and thallium also we have. Rubidium we do not have. So this is not the correct. Third is not correct. Only option set one is correct. That is boron, aluminum, gallium. And they having beryllium, which is not from the group 13, but yet so the similarity property due to the diagonal relationship. So which of the following is correct, beta? Only one, right? That is boron, aluminum, gallium, and beryllium. This option third is rejected because here they use rubidium. So rubidium is not the part of the second group, right? Chalo. Move to the next question, that is 78. A sample of the charcoal weighing 9 gram was brought into contact with the gas contained in the closed vessel of 1 liter capacity at 300 Kelvin. The pressure of the gas was found to fall from 700 to 400 mm. Calculate the volume of the gas that is absorbed per gram of the absorbent under the condition of the experiment if the density of the charcoal is given. So this question is from the surface chemistry, right? So you have to calculate this. So let me calculate the value for this. So we know the formula, that is we can calculate by using the formula like, right. So we know this, that we have the formula that is P1 V1 is equal to P2 V2. So from here you'll calculate actually V2, right? So V2 comes out to be P1 into V1 divided by P2. So we know the value like 700, and V1 is that is 1,000 divided by 400. So the value comes out to be 1750 milliliter. So this is the volume V2, right? So this is the volume V2. Now, actual volume of the flask. What is the actual volume of the flask, beta? So the actual volume of flask. So the actual volume of flask is nothing but just subtract the 1,000 minus volume of the charcoal, hmm, which all I already calculated. Volume of the charcoal. So it comes out to be 1,000 minus. How will you calculate the volume of the charcoal, beta? That is density is given. So density divided by the mass divided by the density. That is mass is 9 and density is equal to 1.50. So this comes out to be 994 ml. So this comes out to be 994 ml. So the volume of the gas absorbed, we have to calculate now. So volume of gas absorbed. Hmm. So volume of the gas absorbed is nothing but is equal to 1715 minus 994 ml. So it comes out to be 756 ml. Okay. Now, volume of the gas absorbed per gram of the charcoal, they're asking per gram. So for converting per gram, just divided with the mass, that is 9. So it comes out to be 84 milliliter. That is this one. So 84 milliliter is the correct one, right? Because they're asking per gram. So this is the correct one. ठीक है? तो इस तरीके से हम लोग कर सकते हैं क्वेश्चन नंबर 17. Now, move to the next question. That is, how many coulombs of electricity is required for the oxidation of 1 mole of water to dioxygen? This is very simple question. 1 mole of water, that is H2O. So it will decompose to give H plus half O2 and 2E electron. So only 2E, that is 2F of electricity. So 2 into 96,500. So this much charge is required by this, right? So its value comes out to be 193,000, yani कितना हो गया 1.93, that is 79, yeah, D. So 1.93 on solving you'll get na 1.93 into 10 की power 5 coulomb. So this is the correct one. So this is a very simple question. Now, move to the question number 80. So, in the following sets of ion, which one is a not isoelectronic with the rest of this species, right? So, this is again a very simple question from the periodic classification, right? So we all they all having the 10 electrons, right? They all having the 10 electrons because oxygen having 8 negative, it becomes 10. Fluorine having 9, they having one negative charge, so it become 10. So they all having the 10 electrons. So only sodium, because sodium having the 11 electrons, so they are not isoelectronic with them. Okay, so it's a very simple question. Now move to the question number 81. For the equilibrium, calcium carbonate will give CaO plus CO2. Kp is already given. 50 gram of CaCO3 in the 10-liter closed vessel is heated to 1000 Kelvin. Now, percentage of CaCO3 that remains unreacted at equilibrium, they are basically asking. So, let me solve the question, right, by applying the some ideal gas equation. So, here we have CaCO3. They will decompose to give CaO plus CO2. Now, Kc for concentration of CO2 and Kp, we can say that, we can say pressure of CO2. So this is Kc and Kp are the method of expressing the concentration at equilibrium, either in terms of pressure, in terms of concentration. Now, the number of moles of CaCO3. So the number of moles of CaCO3 is nothing but mass divided by the molar mass. Mass divided by the molar mass. So it comes out to be 50 divided by 100, or we can say that 0.5. कितना है ये? 0.5. So this is the number of mole of CaCO3. Now apply the ideal gas equation. We can say that PV is equal to what? nRT. So P we have 1.64 and volume is 10 already given. The pressure is 1.64 kp and V is already given. And we have to calculate R, we know 0.082 and this T is 1000, right? 1000 Kelvin already given. So from here also you can calculate the number of moles, right? So the number of mole unreacted of CaCO3 is nothing but when you calculate the value of N here, na, you'll get the value of n is 0.2, 0.2, right? So you'll get the value like 0.2. So percentage of number of mole unreacted, right? You need to calculate. So number of mole unreacted. So number of mole unreacted is nothing but 0.5 minus 0.2. So it comes out to be 0.3. So in terms of percentage, when you want to calculate 0.3 का percentage कितना होगा? So 0.3 divided by 0.5 total into 100. So it comes out to be 60%. So the correct option is C. That is 60%. ठीक है? Move to the next question, beta. That is question number 82. So delta H of solution is expected to be positive. So ये question भी हमारा solution chapter से है. So if the solute solvent interaction is much more less than the solvent solvent and solute solute interaction, always remember beta, डेल्टा एच ऑफ सॉल्यूशन मतलब वेपर कब बनेगा ज्यादा, वेपर और वेपर फॉर्म only when the force of attraction between the solute and solvent is very very less. If the force of attraction between solid and solvent is more, then the vapor less vapor will be produced, or we say less enthalpy. So delta S is expected to be positive when the solid solvent interaction are much more less. So B option is absolutely correct. This is a very simple question. Now, which of the following carbocation is expected to be most stable? So we have a NO2, NO2, NO2 electron withdrawing group. Here we have a carbocation at this position. We have a carbocation at this meta position and this para position. They are asking which of the following is much more stable. So we all know this thing better, that is NO2 group exhibit minus I effect, right? NO2 group is exhibiting minus I effect, hence it is a meta-directing group. The carbocation is an intermediate formed in the electrophilic substitution reaction. We all know this. So option A is stable because carbocation NO2 is a meta-directing group. So this one is very much stable, right? A, because this is a meta-directing group. How will you say meta? This is a carbocation, right? So we can say that this is a meta directing group. That's why they are much more stable. ठीक है, तो ये मेटा पोजीशन से प्रॉब्लम है ना, ये मेटा पोजीशन है एक्स एंड वाई, so they are much more stable. Now move to the question number 84, beta. So in the question number 84 they are asking product. You have need to calculate the product for this reaction when they are treated with the H plus. So when they are treated with the H plus, right, what you will get basically, let me draw the structure here. So we have structure like this thing, and this we have methyl group, another methyl group, and here we have a OH group. And when they are treated with the H plus, right, then H2 will be removed, this OH and this will H, so H2O will be removed, so they will form basically this double bond, right? And here we have a methyl group, two methyl group we have, and here we have a positive charge. Now here methyl shift will take place, methyl shift. So this methyl shift will take place and this will form like this. So they are having Me. Here also we have a Me, and this positive charge goes to this position. Okay. Similarly, in the next, this minus H plus will be removed and we'll get the compound like this. Double bond, double bond. We have a one methyl group here, one methyl group here, right? So this is what we have. And in next position also, that is a H plus addition will take place. So this will become structure like this, and this we have a Me group. This again we have Me group. So this will finally got. So both A and C, that is both A and C. So this product we also get and this product we also get. So both A and C, this one and this one, both are the correct one. Okay. Chalo, move to the next question. That is, which of the following compound is covalent in nature? So very simple question, beta. We all know that a silicon having the four covalent bond. So we can say that silicon, as it belong to the group 14 also. So they are sharing four electron. So we can say that this silicon form the covalent compound. Now, the next question is, that is the halide the halide which is not hydrolyzed is. So you have to identify which halide do not hydrolyze. So it's also a very, very simple question, beta, because here CCl4 carbon is not hydrolyzed due to the absence of vacant d orbital. So carbon do not having the vacant d orbital, carbon having only 1s2, 2s2, and 2p, 2 configuration, 2 to 4 to 6, right? So they do not having any 3d orbital. So we can say that this halide CCl4 is not hydrolyzed. Now, move to the next question, 87. That is the number of unhybrid orbital in each carbon atom of benzene molecule is. So, carbon, we all know that that is sp2, है ना? So, we all know that that is the number of unhybrid orbital in each one of the following. So, benzene is, this is the structure of benzene, right? So benzene all having the sp2 hybridization. So the number of unhybrid, that is 1. That is the A option is correct. Now, move to the next question, beta. That is the enthalpy change and the entropy change for the process is this. You have to find the spontaneity. So from the gift free energy, you all know that is delta G is equal to delta H minus T delta S. If this delta G value comes out to be negative, then this process had to be spontaneous. So what is the delta H here? So delta H is given, that is 350 kilojoule minus this is the temperature we have, and entropy is that is a 2 kilojoule, है ना? 2 kilojoule. So this is a 350 and temperature is also given, right? 300. So we can write as 300 and this is 2 kilojoule. So this is again 2 kilojoule, kilojoule, units are same. So this comes out to be 350 minus 600. So value comes out to be negative. So whenever delta G value is negative, we can say that the process is spontaneous. If this value comes out to be negative, then the process is non-spontaneous. So here the option is A option is correct. Now, which of the following statement about the amorphous solid is incorrect? So this is again from the solid state beta. That is which statement about the amorphous solid is incorrect. So that is they are anisotropic. So they are isotropic beta. They are isotropic. They possess the same property in any direction. Anisotropic means they are having the different property in different direction. So this is wrong about the amorphous solid. Now, move to the next question. That is the type of hybridization of the carbon atom noted as 1 and 2. So you have to calculate the hybridization, right? So let me calculate the hybridization. So here we have a double bond. So we can say that we have a CH2 and this is single, right? So here 90, this is 91, right? So this is like 1 and 2 we need to calculate only, right? So in 1 we have a 3 and 1, right? So Cn, so Cn having one sigma bond here and one sigma 2. So 2 means only sp. So 1 having the sp1 and the two having the one sigma bond here, one sigma bond here, and one sigma bond with hydrogen. So they having the two sigma bond and three sigma bond. So we can say the sp2, right? How will you calculate the sigma bond beta? Because in the triple bond, only one sigma bond is present, while the two pi bonds are present. So one sigma bond here and one sigma bond. So only two sigma bond means sp. And if you have a three sigma bond, then sp2. So the correct option is B. Move to the question number 92. Among the sodium sulfate, calcium chloride, aluminum sulfate, ammonium chloride, the most effective coagulating agent for the Sb2S3 solution is, right? So the best is aluminum sulfate. Why beta? Because aluminum Al2SO4 3, right? We hear aluminum now. This is sulfate. Aluminum valency 3. So formula is Al2SO4 thrice. So why? Because aluminum having plus 3 charge, and according to the Hardy-Squeeze rule for the negative coagulation, because the Sb2SCH3 is a negative salt. So for the coagulating of negative salt, we need a those elements which having the highest positive or highest valency. So aluminum having the plus 3 valency, that's why they are used. They having the plus 3 oxidation state. So they are used as a coagulating agent. Okay? Chalo. Move to the next question, that is 93. So which one of the following aqueous 1 molar solution has the highest freezing point? Highest freezing point beta. So for the lowest, we know wherever I is greater, we have a lowest. Similarly, we have a I have a lowest, then this will show the highest freezing point. So urea, because we all know that urea having I only one, this is a covalent compound. So we can say that they're having the highest freezing point. So whenever they are asking lower freezing point, then you go with higher value of I. Whenever they are asking the highest freezing point, you go with the lower value of I. So only urea, because barium chloride having the I value is equal to 3, and aluminum sulfate also I is equal to 2, 3, 5, and the potassium bromide also we have I is equal to 2. So the correct answer is urea. Now, move to the next question, that is 94. So, in the hexagonal closed packing of the sphere in the three-dimensional, you have to calculate. That is, there are six octahedral voids, right? So, in the hexagonal closed packing of the spheres in the three-dimensional, there are six octahedral voids. So, this is absolutely correct. That is A, B, A, B, A, B. This type of pattern is repeated. So, we can say that the number of octahedral voids is six. Okay? Chalo. Move to the next question, that is 95. When an electrons make a transition from L shell to M shell. L shell to M shell. So we have a K shell, L and M, right? So when the transition move from L to M shell, what is happening? Energy is emitted, energy is absorbed. So basically they are transferring from L to M na beta. So whenever they are transferring from lower energy to higher energy, energy is absorbed. Whenever they are moving from higher to lower, then energy are emitted. So the correct option is energy is absorbed. Okay. The next question is question number 96 beta. The average osmotic pressure of the human blood is 7.8 bar at 27 degrees Celsius. What is the concentration of an aqueous NaCl solution that could be injected in the bloodstream? So we all know this thing, that is the osmotic pressure, that is pi is in nothing but is equal to CRT into I, right? Now you need to calculate the concentration. So this concentration comes out to be pi upon RT into I. So here we have pi is equal to 7.8. R is equal to, we have I is equal to 2 in this case because NaCl. So NaCl having only 1 mole of Na, 1 mole of Cl. So we can say NaCl having I 2. R having the value 8.314. And let's do with the temperature. So temperature is 273.27. That is 300 Kelvin. So on solving, you'll get around 156.4 mole per m cube, right? So in a liter you want to calculate, so value comes out to be around 0.16 mole per liter, right? So which option is correct, beta? So option A, that is 0.16 mole per liter is correct, because this is 156.4 mole per meter cube. So when you convert this meter cube into liter, you'll get this value. Now, move to the question number 97. That is the number of stereomerism for the compound CH3CHBr, CH3Br, COOH. Right. So you all know that the compound contains the two asymmetric carbon. Here N is equal to 2. So the number of stereomerism is nothing but 2 raised to the power 2. That is 4. So this is the formula we use for the calculating of the stereoisomer. So the value is 4. So just need to calculate the carbon, right? The basically the carbon which having the asymmetric carbon. So we have only two asymmetric carbon here and here. So we can say that the value is 4. Now move to the next last two question. That is the this one. You have to, in this they are asking about the major product, right? What is the major product for this? So in this, basically the Marconi's rule and the methyl shift also takes place. So the correct answer is A. How we can say that? This is a negative and this is the positive. According to this, negative part goes to those carbon which contain the lesser number of these all things we already know. So here we know this thing is happening. That is they having the C and they having the CS3 and CS3, right? So product is formed like this is the CH3, hmm? This is the C, there again CH3 we have, right? And this we having Br, and this is again CH, this is CH3 and this is CH3. So due to the methyl shift only, right, it involves the CH3 shift from the more stable carbocation. So the product is A. Now, move to the last question, that is consider the following statement about the following two structure, A and B, right? And they are asking A and B are the geometrical isomer to each other, or A is a stronger acid than B, right? And third, they're asking B can form anhydride easily, but A does not. So you have to find which one of the following is the correct one, right? whether A or B is a strongest acid or not, or whether they will form this reaction or not. Okay. So always remember, beta, that is malic acid, right? That is malic acid B, which is a malic acid. This is known as malic acid. Malic acid. And A is known as fumaric acid. A is known as fumaric acid. So the malic acid is a stronger acid than a fumaric acid because of the stabilization of the mono ion by the H bonding in the malic acid. So we can say that that is first and third, that is A and B are the geometrical isomers of each other, and B can form anhydride easily, but A does not. So these all formula are correct, right? So the correct option is C. So this is all question. So we already discussed all the important question for this paper AIT 3. So I hope you understood this thing. So try to solve these questions once again. Try to solve question on your own self. एक बार try करो, देखो. So and you'll get the solution very easily, right? So thank you all, and next class में मिलेंगे, and then we are going to start a new session, right? So thank you all for your